Oh, hey, welcome back. I just need to get dry. I had a little trouble with the canoe back there. Where were we? Ah, right. Implementing our shake detector. Everything is initialized for us, but now we need to register our sensor event listener with the sensor manager. Android system services like the sensor manager are always running in the background. They use a publish-subscribe method of communication where listeners subscribe or register for updates published by that service. When our shake detector is properly registered, the sensor manager will send notifications to it when the accelerometer detects a change. This is a little different from our earlier listeners because the sensor manager isn't an internal part of our own app, so it communicates with our app in a slightly different way. So here in the onCreate method, we've initialized our variables and have our onShake method all set. We are going to register our shake detector here as well, but this will only be temporary to illustrate an important point about using system services. Below the onShake listener code, add a new line and type mSensorManager dot register listener. In IntelliSense, notice that the first and third methods have little lines through the circles on the left. This means that these methods are deprecated. Deprecated means that these are basically older methods that have been replaced by newer ones that we should use instead. We can still technically use deprecated methods here, but it's discouraged. Select the second match in IntelliSense and hit Enter. The first parameter is our shake detector. Notice that the exact type here is sensor event listener. If I open up the shakedetector.java file, we can see that it implements the sensor event listener. This means that our shake detector can act as a stand-in where a sensor event listener is expected. So let's switch back and type mShakeDetector for our first parameter. The next parameter is the sensor we want to listen to, so type mAccelerometer. And the last parameter is the rate for how often we want to receive sensor events in our app. Let's use a constant provided by the Sensor Manager class. Type SensorManager dot sensor. And then in IntelliSense, take a look at the constant SensorDelayUI. The real value of this constant is 2, but what matters for us is that it says this is a rate suitable for user interface. UI stands for user interface, by the way. This rate parameter must be one of these sensor delay constants, so hit Enter to use this UI parameter. Add our semicolon, and then I'm going to drop this third parameter on a new line for better readability. When we're making a call to a method, we can put the parameters on new lines if it helps to make it more readable. Now, before we get too excited and test this out, and then show our friends, and then publish it on Google Play, and then make millions, I have to point out one major problem with this code. It's something we haven't talked about yet that's new because we're using a system service. Let's take a look at the Android developer documentation about Sensor Manager. Notice this part here. Always make sure to disable sensors you don't need, especially when your activity is paused. Failing to do so can drain the battery in just a few hours. Note that the system will not disable sensors automatically when the screen turns off. Okay, what does this mean? We just learned that these system services are constantly running in the background, but when we register a listener for them, in effect, we're bringing them to the foreground. That means that the service will be running at full power continuously until we tell it to stop. That last part is important, so I'll say it again. We need to stop using system services like this to free them up to return to the background. The sample code here is actually pretty similar to what we're doing. It shows getting the sensor service and then the accelerometer, but it registers the listener in a new method called onResume. Also, it has a line we don't have yet in onPause to unregister the listener. This is the line that tells the Sensor Manager system service, "Okay, we're done with you. Thanks for your hard work." Let's make our code look like the example. Cut the register listener line on line 45. Now, on a new line after the onCreate method, type the following: @override with a capital O, then a new line, and type public void on resume, open close parentheses, open curly brace, and hit enter. Then add another method after the closing curly brace. Type @override again, then type public void on pause, open close parentheses, open curly brace, and hit enter. Before we forget, let's paste that line we cut in the onResume method, right here. These two methods, onResume and onPause, are from the base activity class, just like the onCreate method we've been working in. And, just like that method, these definitions override the definitions that exist in the activity class. That's why we have these special override annotations above the method declarations. Look at the onCreate method. Notice that the very first line says super.onCreate. Remember that this main activity class we're working in is a subclass of the activity class. Looking at this from the other side, the activity class is the parent or superclass of our main activity class. Java has a special keyword called super that always refers to the parent class. So using super.onCreate is a way to run the original onCreate code that's in the activity class. Then our code picks up here on the next line when that first method is done. We want to do the same thing in the two methods we added. And you almost always want the call to the super method to be the very first line in your override method. So in onResume, on the first line type super.onResume. And then in onPause, type super.onPause. The last thing we need is to unregister our shake detector, just like we saw in the example code. So in onPause, add another line and type mSensorManager dot unregister listener. Then for the parameter, type mShakeDetector. Add our semicolon and save. That's all the code we need. But you may be looking at this and wondering, when the heck do these methods get called? The answer is provided by something called the Activity Lifecycle. When we're using our app and our main activity screen is showing on our emulator, main activity is in the activity running state here in the middle. The activity launched state at the top is the first state when our app is launched. To get to the running state, Android actually calls three different methods. First onCreate, then onStart, then onResume. That gets us into the running state. We've been working in the onCreate method up until now, meaning that the code we've written gets run when the activity is first created. The next two methods also get called when the activity is first created, but they get called again while our app is running for different reasons. For example, let's say we're using the Crystal Ball app when we receive a phone call. First, the onPause method is called, and any code there is run, which includes the line we added to unregister the listener for the accelerometer. This means that our app no longer receives updates from the accelerometer, which saves battery and processing power. The onStop activity is then called because our activity will be replaced by the phone activity. Now, when we hang up from the call, our activity will again come into the foreground. For now, let's just look at what happens on the right side of this diagram. The onRestart method is called, then onStart, which is where we register our accelerometer listener. Notice that onCreate does not get called again in this scenario. That means that if we register the listener in onCreate, like we had before, then a phone call or some other like event would break our app when the call was over. onCreate wouldn't be called, so the listener wouldn't be registered, so the shake detection wouldn't work. I know this seems a little complex, but this activity lifecycle is very important to understand. We'll cover it in more detail in the future, but it's a good idea to study this diagram and read through the rest of the lifecycle documentation on this page. You won't need to worry about it for many things, like everything we've done up until this point, but it's essential to get it right when you're dealing with things like system services or user data. Alright, so we're all done with the code, but now we need to see how to test it on an actual device. Let's review what we've done so far, and then we'll pick up with running our app on a phone.